All right, we got a bunch to get through. It's all on your own paper. Probably will take up 2 or 3 pages, just so you know. Okay? Okay? The first 3 are graphs. You don't have to be exact with your graphs, but you need to at least have them graphed. Okay? Here we go. So we want to graph this first function. Okay? Then we want to calculate the x-intercept. We want to calculate the y-intercept. And we also want to calculate when the function will have a value of 200. Okay? Well, that's going to require us to probably make ourselves a nice little t-chart. Okay? A y-intercept is actually pretty easy to figure out, right? How do I find a y-intercept? Plug in 0 for x. Okay? Y-intercept is where x is 0. Okay? So if I plug in 0 into my function, 0 minus 3 is negative 3. 4 to the negative 3 power is 1/64. 1/64 times 1/2. 1 over 128. Okay? So now I'm sitting at 1 over 128 minus 1. But instead of writing it as 1, what am I going to write it as? 128 over 128. So my y-intercept is at 0, comma, negative 127 over 128. Goofy fraction, yes? But what's it almost equal to? Negative 1, right? So it's down right tight to negative 1. Okay? We'll get to the x-intercept later, but let's make this easier on ourselves. If I was to be graphing this one and I wasn't asked what's the x-intercept, what's the y-intercept, the first thing that I would do is I would want my exponent, I would want to figure out an x value for my exponent to be 0 and to be 1. Okay, because those are the easy ones. Okay, so if I want an x value for that to be 0, then that's an x value of 3. 3 minus 3 is 0. 4 to the 0 power is 1. 1 times 1/2 is 1/2. 1/2 minus 1 is negative 1/2. An x value, or excuse me, an exponent value of 1 then would be 4. 4 minus 3 is 1. 4 to the first power is 4 times 1/2 is 2 minus 1 is 1. Could probably do one more. 5. 5 minus 3 is 2. 4 squared is 8. 8 times 1/2, excuse me, 4 squared is 16. I got ahead of myself. 4 squared is 16 times 1/2 is 8 minus 1 is 7. I can now graph my function. I can add in my y-intercept, or excuse me, my horizontal axes. In this case, it is y equals negative 1. And I get that from the vertical shift after the function. Two things left to calculate. We want to calculate the x-intercept. That is where y is equal to 0. So I would need to solve the function 0 equals 1/2 times 4 to the x minus 3 power, then minus 1. And I need to know where that function is 200. So likewise, same thing, solving that function. Okay. We'll take blue first. First step in blue. Add 1. Second step in blue. Divide by 1/2. Dividing by 1/2 is the same as multiplying by 2. Now what? Two equals 4 to the x minus 3 power. What do we do next? How do I know that x minus 3 equals 1/2? Okay, that works out in this case, but what if it wasn't? Like in the next one, it's not going to work out so nice and pretty like that. So what do I do here? I put it in logarithm form, right? Because it's an exponential, so I put it into logarithmic form. So this would be log base 4 of 2 equals x minus 3. What exponent do I put on 4 to get 2? 1/2. Yep. Okay. So that's where the 1/2 comes from. And then add 3. So my x-intercept is 7/2, 0. Over here in getting it equal to 200, add 1 again. Multiply by 2. Switch forms. Add 3. Okay. So if we were asking for it in exact form, this would be that. Okay. If we were asking for it in exact form. If we are asking for it rounded, then you can go to the calculators and you can figure out what it is. And I get here 7.325526. So we could also say that x is equal to 7.326. Okay. graph me this function, answer me these 4 questions. Yeah? Go for it. Y-intercept is where x is 0. So 3/2 to the 0 power is 1, times 9 is 9, plus 1 is 10. 300 divided by 10 is 30. So I get a y-intercept of 0, 30. Is there an x-intercept? Why not? Why is there not an x-intercept? There's a horizontal asymptote at 0. Is there any other horizontal asymptotes at 300? Is this a logistical growth or a logistical decay? You've given me both twice. Why is it a decay? Because it's opposite the exponential, right? So that exponential is a growth, which means it's a logistical decay. Yep. So this is a logistical decay. When will the function have a value of 200? So now we set the function equal to 200. Then I can subtract 1. Then I can divide by 9. Then I can switch forms. Then I can calculate it. So I get an x value of negative 7.129. There. When will the function have a value of 500? Why not? Above the limit to growth. Okay. Yep. The limit to growth is 300, so it will never have a value of 500. Questions on that one? Try this one. Y-intercept is where x is 0. 0 plus 1 is 1. Log base 3 of 1 is 0. 0 times 2 is 0. Minus 2 is negative 2. So my y-intercept is 0, comma, negative 2. The x-intercept is where y is 0. So that would be 0 then equals 2 log base 3 of x plus 1 minus 2. So I would add 2 to both sides. I would divide by 2. Then I would switch forms with it. So this would become 3 to the first power equals x plus 1. 3 to the first power is just 3. So then I could subtract 1 and get x is 2. So my y-intercept, excuse me, my x-intercept would be 2, comma, 0. This is a logarithmic function, so it's going to have a vertical asymptote, and that vertical asymptote is going to be at x equals negative 1. And I get that from this part right here. I think opposite on that one because it is inside a set of parentheses. Okay, so I think oppositely about that one, which means then my function, bad function. Looks like that. When will the function have a value of 200? So 200 here is going to equal 2 log base 3 of x plus 1, then minus 2. Add 2 to both sides. Divide by 2. Switch forms. Type it in your calculator, then subtract 1, and you get x here is equal to 1, 5, 4, 6, 1, 3, 2, 5, 6, 2, 1, 9, 6, 0, 3, 3, 9, 9, 3, 1, 0, 9, 3, 8, 3, 3, 8, 9, 2, 9, 6, 8, 6, 381 810 632 256 6002. Yep. I don't even know what that is. So hundreds, thousands, millions, billions, trillions. What goes up? Like we're talking way past trillions.
Quadrillions,
Quad, pent, quint, hex, sept, oct, non. So then this would be dodeca. I don't know what, whatever 13, whatever the 13th is. Yeah. Yeah. Yep. It's a lot of, yeah, it's like 10 to the something. I don't know, my calculator gave it to me exactly. Like I typed 3 to the 101 power and they gave it to me like that. They gave it to me. But yours might, because yours is different than what I use. 48? Yeah. There's a lot in there. All right, expand this log, please. Oops, I almost put 5 again. Should be 2. I get 3 plus 1/2 log base 5 of x minus 5 log base 5 of y minus 2 log base 5 of z. Because 125 is 5 cubed. So what exponent do I have to put on 5 to get 125? That's 3. So that is a good. Condense this log. I get the natural log of the fraction z cubed square root of x all over e y to the 5th. Questions? Go ahead, Alec. Because it's plus. because the order doesn't matter when we're adding, right? So we could have written this here as natural log of x to the 1/2 plus natural log of z cubed minus natural log of y to the 5th minus natural log of e. Pluses go on top, minuses go on the bottom. Because what is natural log? Log base e, right? Okay. So yesterday we did 2 or 3 of them where we simplified natural log of e to 1. Because so what exponent do I have to put on e to get e? 1. Okay? Solve those two. Now, I'll give you a preview of next week, Thursday. Okay? We are kicking around the idea of giving you all of that as a problem. Okay? So we'll give you the problem, we'll give you each step, we'll give you the answer. What would we be asking of you? Nope. All right. What could we ask you? Explain what the work is. You have to show the work. So for instance, in this first one, you would have to show you added 1 to both sides. Or you would say, add 1 to both sides. Then divide by 4. Then here, equal bases means equal exponents. Then subtract 1 to both sides, and so on and so forth. Where we're going to grade the work, that you know how to do the work, not just the answer. Okay? That is a potential test question next week, Thursday. Okay? Try these two, just one. get x equals 1 for the first one. I got no solution for the second one. Why? Why do I get no solution for the bottom one? Oh, it should be negative 3 halves. I'm sorry. My fault. Argument can't be negative in a log, right? Okay. So if I go back up here to the original problem, if I plug in negative 3 halves right here in the first one, I get negative 9 halves. Okay? That can't happen. Log base 8 of negative 9 halves does not exist. That's an error. So that one gets tossed out. If I plug negative 1 in that same spot, okay? Log base 8 of negative 4 can't happen. Get an error message. So both of them get kicked out, leaves me with no solution. Okay? Yep. Try that one. Negative 5 is going to drop out because we can't have log base 3 of negative 9. But the other two work. So x here is going to just equal 7. Add 5 first. divide by 3. Switch forms. Subtract 1. Divide by 2. I get 0.540. Questions on either one of those two? Create for me the logistical function given those conditions. So my initial value of 10 would be the point 0, 10. So I can utilize that. My y value is 10. My limit to growth is 500. X is 0. B to the 0 power is 1. So that's just 10 equals 500 over 1 plus a. So 1 plus a is going to be 500 divided by 10, or 50. So I get an a value of 49. If it goes through the point 2, 50, then I can say 50 equals 500 times 1, or divided by 1 plus 49 b squared now. So 1 plus 49 b squared is going to be 500 divided by 50. So 1 plus 49 b squared is going to be 10. I can subtract 1. I can divide by 49. And I can square root both sides. Now, normally I'd have to add in the plus or the minus there, but my b value can't be negative, can only be positive, so I don't have to in this particular case. So my b value is 3 seconds. So there is my logistical function to go along with that. Okay? Tomorrow you will have a formative in class. There is a staple in it.